I said it's amazing how much mucus is still in my face.
Cool. That is how we started the stream. Actually, say it again so I can test the audio.
It's amazing how much mucus is in my face.
Okay, yeah. I think we're live.
For the whole week
What?
that I've been sick.
Oh, yeah. Joelle's sick too. Maybe I'll get sick.
I mean, it's not really fun. And then I just have this like dry cough every once in a while. I did a rapid test and it was negative for COVID, but you know, it's not 100% accurate.
Mm-hmm. Well, were you on the last? Did we not do it? I forget last week. I know Monday I did a stream without you, I think.
Yeah, I was here on Wednesday.
Oh, okay.
Yeah. We did a short one. You kind of went over the state of things and you
Oh,
reviewed
okay. Yeah.
a few like bugs.
Yeah.
Issues.
Yeah. Let's take a look. Actually, it doesn't look like this anymore. I had an old tab open and I wanted to start with this because it doesn't look like this anymore. I'm going to hit reload and it'll look different. Let's see how it looks. Whoa. I was trying out that theme that I showed you. And those previews are kind of lame because they don't really give you a sense of how it'll actually look, because in the terminal, you really only see like 3 or 4 colors.
Yeah, it's pretty unrealistic.
So, but whatever, I like the idea of coming up with some kind of distinctive theme for it.
Do you want to make our own? Do you want to
We might
use this?
I don't know. There are let's see, what was that link? Bunch of terminal themes. This is the one that I was trying to replicate. I actually I took this image and I tried to throw it into Claude and be like, give me the hex codes for these colors just to see how good it could do, and it did a very bad job.
Yeah, I can imagine.
Most of these
you can't just because you have custom CSS or whatever. You can't like.
I wish it was CSS. It's actually like a big JavaScript object.
Oh.
But anyway, this one seemed like it could be cool. I wanted to do something different than white on black or even just black background. Some of these, white's cool, but it's also kind of boring. But this off-white is like a little too warm. I don't know. I'll be very picky about this, just to warn you.
Yeah, I mean, it's definitely personal preference. I would say for like eye strain, a gray might be better than white.
I kind of like this one.
I wouldn't really want a white. If you want, I can check. I pulled the other screenshot into Figma, but I haven't checked it yet for contrast. I know you were worried about that, but I can check it against like the contrast standards.
Yeah, try. I mean, Mariana. Maybe I just like it because it's higher resolution and it looks sharper. But these colors are cool. Or any of these could be like a base.
Yeah, no, I mean, that seems kind of classic,
Yeah.
but interesting.
Yeah, it's instead of black, it's gray, but it's still black-like. Because I think, let's see, do I still have the default? The Apple terminal is black on white. Which, when I saw that, I was like, that's lame. But I kind of like it in a way. I don't know. It's different.
Yeah.
That's the thing, is it stands out.
Yeah, but I mean, yes. But you also want something that's, I feel like we should prioritize eye comfort as well. I honestly don't know.
I don't think black on white is not comfortable, but I mean, I don't know. Yeah, I don't know.
Well, the thing is, it's bright. Like, it's a lot more.
I guess it depends on if you're in like dark mode. But yeah, you're right.
I'm surprised Apple would do that. Yeah, I wonder if you have your Apple system settings to dark mode, does it switch it?
Well, that's a good question. Oh yeah, this is kind of got that retro old CRT look. There was green on black, I think is overplayed, even though I was pretty into that when I was younger. Amber on a black is also an old retro thing that you don't see as much.
My terminal's green on black because it makes me feel like a hacker.
Yeah, like this.
Yeah.
I don't know, there's weird stuff. Grass, I mean, that's kind of neat looking.
I kind of like that dark brown one.
Which one?
I'd also, I don't know I forget the name of it.
Was it this one?
No, it was like a dark brown with maybe the amber. I don't know. We just looked at it. Maybe before the. Yeah, maybe that one.
Maybe it was this. No, it was a different. I think it was this one, Jackie Brown.
Yeah.
I mean, this is the one that I was looking at, but.
And it also reminds me, a little bit of the vibe of the Wanix website.
Uh-huh. So anyway, well, we can try some of these out. But I hate this website because you really just have to look at this left side to get a feel for it, because you usually don't see all this stuff on the right. But in terms of like vibe, this image does not represent the vibe you will actually get.
Yeah, it's pretty stupid.
Anyway, I also just made the font something a little more modern. I made it bigger. So that's a stupid thing that I did. But let's look at this plan here.
Well, anyway, it looks good so far.
Yeah, thanks. It'll get better, and it would be nice for it to stand out when it's released. There were 3 bugs here that we talked about last time. I've almost finished one. It turned out to be a huge ordeal. And then I feel like these 2, we could just, it's a preview release, and so I could just say, here's some bugs. Help me fix them. But I did a bunch of stuff besides that theming thing. Actually, one little concept that I wanted to do, but kind of like NV86, we can like run a headless browser, run Wanix in a headless browser, and then give you a console. So look, it's Wanix in the terminal. Don't even need the browser.
That's cool.
And of course, it's themed to whatever your terminal is. I guess it's a different domain, so OPFS is empty. But it's very raw. There are things that are broken, like I can't get out of it. I have to do D, and then there's an error, and then I do C. Control D, Control C. But anyway, it's there. Another thing, and I guess this came up because I was messing around with the, the page that this is on. Plan 9 had this really minimal windowing system. They called it Rio. But is pretty different than windowing systems that we know. Each of these squares is a window. But the way it would work, and they had pretty crazy bindings, like all the mouse buttons, they would do a lot of weird stuff. But basically, I think you would like right click on the background and you could say like new window, and then you would draw the window. You'd like hold down and then make a shape, and then that would create the window, and it would always default to the shell, and then from the shell you could run some other program. And I don't remember because I haven't played with it too much, but I don't remember how you move stuff around. But you'll notice there's no like title bars on these windows.
Yeah.
You did have like, if you right clicked, you could kind of do minimize, close kind of stuff, but that was all through a menu as opposed to UI. But it kind of inspired me, just the simplicity of it, to do something kind of like that, because when we do iframes, I was just thinking it would be cool if you create an iframe on this page under body, that it just treats it like a window. And so I did a prototype of that. It's also buggy and incomplete, but kind of conveys the idea. Let's see. So I'm going to web DOM new iframe, and then append child to web DOM body. So that's an iframe. It's empty. There's nothing loaded, so it's transparent, but it's just chilling there. And the cool thing is you can grab it also selects in the background, but you can grab the border and move it around and resize it. And it doesn't need any like container or anything, because I'm just applying a border to the iframe, which is clickable, and then some JavaScript saying, hey, you can click that border and drag it around, and if you click a corner, it'll resize. So it's just a square, but let's do if I point it to the root here, that'll basically load another Wanix. Well, did before. What is it?
Oh.
Is it because I think because it's wants there to be an actual server running. It's supposed to be local first. Look at that spam in the chat.
Oh, yeah, I'll get it.
Let me try this again. We have to reload though. This could all be wrapped up in a shell command now, but I just haven't done that yet. Let's put it down here, maybe right here. There we go. There we go. Unfortunately, it doesn't get focused, so I can't actually use it. But you get the idea. It's loaded this page in an iframe on this page, and now we can treat it like a little window. And I mean, just like Plan 9, it's a kind of recursive in that you could run Rio inside of a window. And you just keep making nested windowing systems. But yeah, I mean, they didn't have too much, windowing functionality, snapping, or any modern features. And so I was interested in just kind of making a minimal thing. Though the cool thing about Plan 9 windowing system was you could control it all through the file system. You could inspect the state of a window and resize it and hide it and read the contents and get a screenshot of the window all through a file system API. And they did some interesting tricks where, because of namespaces, where every process has its own view of the file system, each of the shells, each of these windows, which is running a shell, has its own namespace, its own view. And the way you get mouse input and keyboard input, you read a file, device, mouse, device, or, /dev/mouse, etc. And they do this multiplexing thing where inside of a window made with Rio, the namespace is set up so that /dev/mouse is only giving you mouse cursor data when your mouse is over your window. So which, to be fair, in a lot of practical applications, if you're like, oh, I want to do something with the mouse, you usually don't want to limit it to just your window. You're like, I want to know when it's in the top right corner or whatever. But by default, it was sort of like constrained to the window. But it was neat that it did that by sort of like overwriting the mouse device file for the namespace of this window. So when you access dev mouse here, it's different than the dev mouse in this window or outside of the windows. It's a special dev mouse that only gives you mouse info when you're over the window. And that's all stuff they did with the namespace and binding stuff that we have set up as well. So we could do something like that. But anyway, this is just a experiment in that direction. Obviously, it would be cool the idea is like, oh, you could, I mean, maybe I don't want to do a full-fledged windowing system. The idea that maybe people could make their own or whatever, because it's sort of like really just a minimal thing, maybe inspiration. I could imagine though something like if you double click the border, it like maximizes it to the full size of the container of the page, and then you can do stuff like load VS Code in a window and maximize it, and double click
Yeah.
again to make it go back to this size and access the terminal in the background.
The border is a pretty small click target, though.
That's true, and I made it a little bit thicker than theirs, but I don't know. We'll see. I thought the same thing, and it hasn't bothered me that much, but all customizable. In theory, it's like, oh, you could change it with CSS. I made a option to show the sort of virtual machine screen output so that I can see how it boots, since I've been doing stuff with the Linux kernel. And if the Linux kernel fails to boot, it outputs here and we don't get anything here. So this helps me see it. But you could imagine that this is just a div that's positioned in the corner, but you could imagine it being a window as well.
Mm-hmm.
So that's cool. And Plan 9's is called Rio. Wanix's could be called Weo.
So the Rio thing is, it's the Windows.
Yeah, but also probably the file system to control the windows. Very similar to the Plan 9 Windows system, but that's really just like it's a straw man windowing system. I like to think of Wanix as a kit to make your own. You know, like Linux isn't really Linux. Linux is a kernel. Linux is not an operating system. The operating systems that you use are like Debian, Ubuntu, which are distributions. They use the Linux ecosystem kit to build an operating system. And I know that that's something that's always been slightly confusing because the average consumer is just like Windows operating system, Mac operating system, and of course Linux operating system, but it's slightly more complicated than that. But the idea that Wanix can be used for a lot of different things, including non sort of operating system things. You're just using it as a way to run or to have a virtual file system in the browser that you can do binds and stuff or whatever. It's like you don't have to. One, there's not a whole lot there in the beginning because it's just like designed to be a couple of simple primitives. But then there's so many different ways you could use them. So like Aptron in a way is almost like, or will almost be like a Wanix distribution, or, you know, something built with the Wanix kit. But then there could be other things. I've been thinking about well, this came up again. I've thought of stuff like this before, but like maybe a Wanix run service. So it's, you know, a hosted version where you get basically this experience, but you're able to log in with GitHub and store kind of some of the functionality that was in the old Wanix demo, where you can store stuff in a repository, and then whenever you go there, you can log in and then see what's in your repository, and your repository can have init scripts so that when you go to Wanix run and you log in, it will be configured however you want. You could change the colors and replace the windowing system, right? Because it's all just scripts that you can run. And if you store those, people do this with the, I don't know if you've seen this, but there are, you know, things like, have you ever looked at, I can't look in them because there are passwords in them, but in your home directory, there are files like profile and like bash rc, or let's see, what are the other dot files, like zsh, and basically there are these files that are just shell scripts in your user directory that z profile, I think, that whenever you load a shell, it's going to run these scripts. So it's like,
yeah, I mean that's how I have the custom colors, right?
That's right. So you've done that, but that's a basic idea that goes back to original Unix and Plan 9. So what some people will do is store those files in GitHub, and then whenever they set up a computer, they like have it check out those files and then symlink them so that all of their computers will have the same like setup scripts.
Yeah, that's smart.
So the idea is we could do kind of something like that with Wanix Run, where because it creates a repository and you can put stuff in it, you can put your startup scripts in there, and then whenever you go to, your domain on Wanix Run, it would basically be your Wanix. And this could serve both as like a demo of Wanix, but maybe something useful. I thought it would be cool maybe someday to get Wanix SH to just be Wanix, but I don't know how far I want to go because of like SEO and things. But with Windows and stuff, you can kind of do these layouts, and I mean they're all web views, iframes, so you can create a version of the website that's just in Wanix. Anyway, those were some other recent thoughts. But the big thing that I was working on that maybe we'll finish today. What was it? Oh, how do I describe this? Well, one thing is we're in a Linux VM here, and the Wanix file system is mounted at /Wanix, which is kind of weird because now you have to know when you're in the Linux context and you want to refer to something in Wanix, you have to kind of prefix it with Wanix, whatever. But a lot of stuff in Wanix doesn't know that. So sometimes you would not do that. Like, all the stuff I was doing before, I was not saying /Wanix because I'm interacting with Wanix, and Wanix doesn't know about Linux. So anyway, that's confusing. So the idea is if you could get the Wanix root to also be the Linux root, then they would be more consistent. The problem is there are things in the Linux root that you need to have. A lot of the stuff you can get rid of. You don't need etc. Maybe you don't need dev. Bin is kind of like whatever. If you're going to have executables, which we have, even though it looks like we have a lot, we really only have two. We have wexec and busybox. And the rest of these are all symlinks to busybox. Which makes busybox behave differently. Whoops. And then it turns out the proc is required. Proc is the Linux version of our kind of /proc, or now it's task. And because it's task, now it can live in here as well, since we can't do Linux without /proc. But the way this works is there's a when we set up the VM, we give it two things. One is the Linux kernel. It's just in a single file called BZ image. Always frustrated by the fact that it doesn't say Linux or kernel in it at all. But the standard convention is called all the Linux kernel BZ image. Because it's an image of the kernel and it's BZ compressed. Funny.
Well, they could call it BZ kernel image.
You would think, but no. Anyway, so we give it that, and then when the VM boots, it loads this little BIOS, which does very little other than figures out how to boot, which usually means load the kernel. So then it loads the kernel, and then the Linux kernel boots up, and then the kernel will then run an init script, like the first process. And then that usually sets up whatever is needed for you to get a shell and all that. But also, it's like, where are the files? Where is that init script? And, all of these things. So there's another file called initramfs. Sometimes it's called other things, but it's basically a little file system that, if you don't have a storage device like a hard drive or whatever, this is sort of like, here's a little file system that just comes with it. So this is, or it's also sometimes called initrd, but it's a way of specifying a little default file system so that if you don't have any storage device or networking or anything, it's like a way to bootstrap a system. So all this is practically a gzip of this directory structure with the init script and our stuff in bin, and some of these are dynamic, so they're not in there. But anyway, this is created in we've got like a build script for Linux, which all happens in Docker. And we build the kernel in here, but we also build the initramfs because we put BusyBox in it and we build BusyBox. You can see we're sort of like staging that root directory by just making a directory with all the directories in it, and then we put stuff in it, like put BusyBox in it. Okay, now we have BusyBox. What else can we put in there? We can put our init script in there. So this is our init script. This is literally the first thing that runs after the kernel has booted. In which case we do BusyBox install, which is setting up all those symlinks. There are a couple of mounts that, because they're dynamic, you have to set them up. So you do mount proc, and then you get proc and sys file system and the dev. These are basically dynamic, so they wouldn't be stored in our initramfs. We have to create them dynamically. And then all this stuff is setting up the Wanix mount and then running a shell in a very complicated way, so that we can do that preload thing to make wexec work. Anyway, that's kind of how this little Linux system works. And the idea was, can we get rid of this initramfs? Can we just have Wanix control the file system that's given to Linux? Because then we can manage this file system through Wanix, not just the Wanix file system, and we can kind of combine them.
Well, do you think it's possible?
Well, that's what I've been working on, but it's been a challenge. So one thing we'd have to do is we'd have to kind of recreate this root in Wanix somehow. So I've just been using, since OPFS is our only real persistent thing right now, I've been setting it up in here in root. So here is kind of a copy, and I'm pretty sure these are just empty. They're not actually dynamic things, but it's basically the same thing as the init ramfs. I kind of recreated it here. Wanix is empty too, I think. Let me get rid of. And then to be able to tell the difference, I added a file so that we know we're not in the normal init ramfs, but we're in the one that we made at Wanix OPFS root. So how do we get it to use this? In theory, it's pretty easy because we're already using 9p to mount /Wanix, and Linux actually has because it has 9p built in, you can actually tell it to set up the root file system over 9p. So the kernel actually sets up the mount, and you can tell it what directory in that service you're going to use. So OPFS root, and also tell it what the init script is in there. So if we do this and turn off the init ramfs and turn off this old, these are arguments to the kernel. What would happen? First of all, when I first did that, it kind of worked, except it didn't. I had to do this with console so that we could see, and this is actually going to work. But basically, the kernel would boot, and then it would give an error about 9p, similar to what it's doing here. These aren't the same thing, but it would be like, oh, 9p isn't working. You wouldn't get a prompt or anything. And I would debug 9p by seeing all the 9p messages over here, and found it had to do with an aspect of the protocol that I was not implementing correctly. And it turned out Joel, he's kind of recreating some of this stuff for his own purposes, somewhat separately, not as part of Wanix, but to kind of help. And he
Interesting.
recreated, because he's building a prototype, and the idea is to build the actual thing with Wanix, but in the meantime he's sort of building some of the pieces on his own because it's already just made with pieces like v86 and the Linux kernel. So, but he found that bug as well, and so he helped me fix that over the weekend. And it was cool because it worked, it went ahead, but then I got all these errors because it tries to run the init script, and the first thing it does is use BusyBox to install all those symlinks into bin. And if we're doing this on the Wanix file system, we have to support symlinks, and we did not support symlinks.
Oh.
So that is one of the big things that I did over the weekend, but we have symlinks now. I fixed the tag issue, added symlinks, which I guess I could show you.
Yes.
Oh, since this isn't working yet, we can't actually use Wanix this way, but we can go back to how it was with the init ramfs. for now. And there's a file in here that's a different color because it's a symlink. And when you list it, it actually shows up as a link and it says what it's pointing at. So it's pointing at file. File just says hi. But if we cat link, we also get hi. We can remove the link. Recreate it. You've made symlinks before, right?
I mean, yes, I still kind of barely understand them, but I know they've screwed me over before.
Yeah, they can do that pretty easily. So symlinks are weird. There's another thing called hard links, which is almost the same thing as binding. You know, when we do binding to like say this file, I'm going to create a file that's actually this other file that's sort of built into the system as a kind of a 9p thing. The way that works is if I made a binding, it would just show up exactly like the other file. I mean, it might have a different name, but it would basically have the same stats as the file, you know, the same everything, because it's literally the same file. It's just another name that points to the same file. And symlinks are kind of like that, but at a different level.
Oh, sorry. So it's a pointer, I guess.
Yeah, it's like that's exactly what it is.
Nice.
And it's a pointer in the same way that you can interact with a pointer separately from the thing that it points to, you know? Like if you do a binding, it's kind of like a pointer, but that you can't actually change what the pointer points to because you just set it up. It's like a built-in structural thing. Whereas a symlink, which actually makes it more complicated, a symlink you can do stuff like another thing I had to do is OPFS, like the standard what the browser supports, implements, you know, what you could call a file system with kind of a weird API. But let's see, get file. Just looking at the API, we can kind of, let's see, where am I looking? Get file, I guess. File object. So file object has last modified. So that's like one. In our file system so far, we have like the idea of a file. And then there is, you can stat a file. I don't remember how much we talked about this. Maybe when we're just getting started.
Yeah, I don't really remember much of that.
But like, okay, conceptually, if you scaled it down, a file system is just a thing where you can open names and get a file, which you can usually both read and write. So basically, it's a way to get bidirectional streams of bytes via a name. That's why it's so powerful, because it's not really like, oh, what is a file? But it's modeling files in this very generic way. A file is just something you read and write bytes to, and you can close to say, I'm done with this thing, in which case it can, depending on how it's implemented, maybe when you write, it doesn't actually write it to disk until you close. It really depends. But But that's kind of what most people think of. If you were to like simplify file systems, it would be like, okay, a file system is a thing where you can open files by a name, and you can, once you have a file open, you can read, write, and close. Maybe you can't write because it's read only, like this kind of implies, but that's pretty good. But there's also this idea that a file has metadata. So this verb stat, which maybe is short for status, maybe something else, I don't know. But convention has become this stat verb will give you metadata about the file. So file info. This is Go's sort of minimal, they're trying to do the lowest common denominator representation, which is, I like that because it's sort of like, this is the simplest representation of a file system. So we have files, we can read, write, close, kind of like a socket or a networking thing or anything like that. But we also have metadata, and metadata will include the name of the file. You know, you want to get the size of the file. There's this whole file mode thing, which is a bit mask, which throws people off because bit masks are weird.
Mm-hmm.
File mode basically covers a bunch of stuff, including permissions, which was the whole like read, write, execute for the owner, for the group, and anonymous. Like that's the whole this stuff. Do you know how to parse these? Do you know what this means?
I mean, I know it means it's like permissions stuff.
Yeah.
That's all I know, really.
Just one of those archaic things, but we've had it forever, since the beginning, I think. And yeah, the basic idea, you've probably heard this before, but forgot, but because it's not super important. Anyway, the first three represent the owner. So if I made this file, I'm the owner. And so I have read permission, write permission, and I can execute it. Execute's kind of weird. What does that mean? That mostly means like if it's a executable, like a binary program that you can run, you need that bit to be able to run it. Mm-hmm. So it's kind of a way to help distinguish executables versus non-executable files. As a permission, it's, you know, maybe you don't want this to be able to be executed, but there's some things like shell scripts, which normally you'd think of are just regular files. You have to give them the execute bit to then be able to run them. Directories will also use the execute bit. I think, I haven't read this, I don't know where this standard spec is, but I think you can't open a directory unless it has the execute bit. So it sort of treats execute like open directory. Roughly, something like that. I don't know if that's true, but that's kind of what I've found. Anyway, so all of this, and then, you know, group is most of the time, we don't care what group, but most Unix and Linux systems, you have a user and there's a group. Like if you've done stuff on Mac, you might have heard like the wheel group. I don't even know what wheel means, why they chose the name wheel, but wheel is the group name for administrators.
No, I have not heard that actually.
But, you know, as a user, you can be in these groups that are created by the system. And so if I'm in a group that has group permissions, then those apply to me. So if this file, these are supposed to be the user and the group, which we don't have, so they're just 0. But it could be like program, and then, I don't know, the admins. Create a group called admins, and program is in admins. If I then put group permissions on here, you could be in admins, and these group permissions would apply to you. So that's groups. It's not really used that often. People don't really use groups on a day-to-day basis. Like even sysadmins running Linux on professionally don't use groups that much. Usually it's just a thing that other old software use groups you have to think about. And then the last one is other, which means any other user that's not the owner or in the group. So you could make a file that I can read and write, but any other user on here can only read. So anyway, that's the permission stuff. And all of this is done with a bit mask, which is crazy, but makes sense because it's very efficient to store. But it is one of those kind of archaic things because bit masks are weird, this whole thing and doing ors and ands and all that. That's kind of a weird programmery thing that we don't have to do as much anymore these days. But luckily we have libraries and languages that kind of abstract that stuff away, so I don't need to know all of the codes for things. I think for permission bits, we don't have anything specific. But anyway, that file mode, it's literally one number. It's a unsigned int 32, which means I believe it takes up 4 bytes if you were to store it. And in those 4 bytes, we can store all of those permissions plus a ton of other stuff. So it's kind of used as a way to identify flags to say, hey, this file is special in some way. For example, hey, it's a directory. So there's a flag to say, hey, this file is a directory. There's a bunch of others. Most of the time, we don't use these. I don't use most of these. But some of them come up a little more often. Symlink is one of them. So it's an actual file mode to make something a symlink. And then what else? There's the mode. There's usually a bunch of times associated with a file, like when was it last accessed? When was it created? For whatever reason, Go decided they're just going to do last modified, because that is usually the thing that you care about most. And they have this helper that's like isdir, but really that's just checking the file mode. Kind of weird that they added that. But that's the general idea of the metadata associated with a file in any Unix-like file system. You've got name, you've got size, you've got file mode, which is a bunch of flags. Then you have a bunch of times. And there could be a bunch of other stuff, which is what this catch-all is for. But all that data is sort of looked up with a command called stat. So metadata command or something like that.
Gotcha.
What was the point of this? I was talking about symlinks. Mm-hmm. One thing was symlinks are files that are marked as a symlink. Maybe the Wikipedia actually has a good... Symlink is short for symbolic link. Do they show storage? But basically all a symlink is a file, and the contents point to what it points to, just like you would imagine a pointer. It's a file that points to another file, and the file that it points to is just in the contents of that file.
So yeah, you were saying that you added support for that because it was necessary for...
Yes, but it was just surprising how hard it was to implement symlinks. there are two sort of commands, APIs I had to add to the system. And one of them is symlink, which is basically what happens when you run this. It's the thing that creates the link, where it takes a target and then the file that you're going to create. Let's see, I put this all in symlink. Here it is. So symlink, they use this weird terminology, old name, new name. I think the way it makes sense is because they use this terminology across a couple of things that have two files, and they wanted to try and have some consistency, where new name is always the file that you're creating. It's the new name. And that new name is pointing to an existing name, aka an old name. But you can see how this also works for rename. Rename is, here's the new name, and then the old name is. So they're trying to be consistent, but that kind of makes this kind of weird and tricky. Symlink, old name, new name. How does that make sense? We could call these whatever, but I'm just trying to be consistent with, these APIs and how they've been over the years.
Yeah, it's probably
there's
for the best.
One command to create them, and then there's another command called read link, which, because if you think about it, the way a symlink works is if you try and read the symlink, you're not going to get the contents of the symlink. You're going to get what it links to. So how do you actually read the contents of the link? There's a read link command that you can implement. And there's also a command for that too. See, this points to a file. Okay, so we could add those. That's easy. The hard part is now you have to resolve those. And there's a couple of tricky things. One was the system doesn't care what a link points to. It's just a string of text. I'm pretty sure we could do, whatever. I probably don't need spaces, and make a bad link. And it doesn't care. It looks like it does maybe do a stat when you do an ls, and because it looks like it's red, so I think it's oh, that doesn't exist. But it doesn't do any validation when you create it. And the other thing is that the link, because it's a path, there's no it could be a relative path. It could be a path that starts with // to be a relative path. I think if you don't have // it assumes it's a relative path. But it could also be an absolute path. And then that ended up being kind of a tricky thing. Because when we're opening up a file in Wanix, we have all these nested, our file system is composed of file systems. So we kind of find the file system where the thing exists. So there's a OPFS file system, and then we open the link, and it's relative to that, regardless of what the path is, in the system. And then the problem is then if it's an absolute path, you don't know where this file system has been mounted, and you don't know what the root is. So if you're trying to open up a file and then suddenly you're going to say, okay, now, but actually open this other file, you need to be able to actually address it. But the way I set things up is when you open up a file, most of the time, all you know is the name of the file. You don't know where in the file system you are, or even have access to the root. But that's why way back in the day, we added all these context versions of things, because context is a great sort of I'm going to throw some more data in here, and I don't need to change the signature or anything. We can just add new values to the context and pull them out. And the idea is that you can pass this context around. So it's sort of, as you're going through all these file systems, you're also passing along the context. So,
which is the path of where you are.
Well, technically, context is a Go thing that's used for things like timeouts and stuff, but you can just put arbitrary values in it. So we can put things like, there are a couple of things now that we use context for. One is this, it's kind of a key value store. So, but there's all this kind of crufty stuff to do it. But basically, you can think of it as a key value store. One of the keys we set up is origin. So that's the first file system, basically the root. So whatever we do, we ultimately start talking to a root file system, which is almost always the namespace. And so we do this thing where we have this helper that takes a context, and then if there is no origin set in it, we'll add an origin. So that way we can, the first origin that's added will always be the origin from then on. And then later we can call origin on the context and it'll give us that file system. Another thing that we store is the file path. So the actual hey, this is the file that I'm trying to open, the full path, from the root. That's stored in there as well. So we can pull that out as well, kind of combine them and say, give me the origin and it'll give me the file system and the full path. So that helps a lot.
Mm-hmm.
Another complicated thing with symlinks is sometimes you don't want them to resolve. Like, how do you, that's why they had to create a separate command to actually get the contents of the file. Because if you were trying to open the command, it would open it. But sometimes, or stat, for example, if you were to stat this file, it's supposed to give you the stats of the thing that it points to. How do you get the metadata for the link itself? So a lot of the time, Linux systems will add extra versions of a lot of the file system commands. Let's see if Claude can tell me all the Linux syscalls for the file system. So open, close, read, write, basic stuff. There are some weird ones. Oh, they don't show them here. But they'll do stuff like, there might be an L open or an L stat. Yeah, there's 3 different versions of stat. The normal stat takes a file path, which makes sense. Give me the metadata for this path. Fstat, and most of the things that start with F usually work with a file descriptor. So that's in the case we've opened this file. Now tell me the stat for this file. That's Fstat. And then Lstat's a weird fucking one that is, it's stat that works exactly like stat, except if the file is a symlink, it will not resolve it. So they made a whole separate command to do stat that doesn't resolve. And you'll see. So it just in a way clutters the API, but it makes sense because you need 2 ways to do it, and you're not going to say stat, hey, they can't change the old stat because it's whatever. Symlinks were added later. But luckily we have context. So when we do a stat or an open, we could pass something in the context that says follow symlinks or not. Okay, so all that set up, and then I had to set all of this stuff up. I ended up cleaning a bunch of stuff up because it started touching on a bunch of things that in order to get it to work, I had to kind of clean up the existing stuff. But here's an example. Oh no, I guess it would be in, I guess these are all just the API. So namespace. And so I have to figure out a way, actually, where? I forgot how all this works. Okay, symlink, read link, find references. Okay, here's a couple. So in memfs is sort of our default in-memory file system. We don't really use it in Wanix yet, maybe for the temporary file system, but it's great to test things. So for example, now when you in a stat or an open, now you have to have this extra code. So file systems kind of have to know to support symlinks. But so when we open, we can use this helper to see if we can follow this, if we're set up to follow symlink. So if we pass like don't follow, then this will return false, but by default it's always true. And then we do a check to see if the file is a symlink, but that it has a flag that says it's a symlink. Then we use read link to get the target. What do we actually want to open instead? And then that might be an absolute. Read link. I'm thinking of some code and I can't remember where it is. That's weird. Follow symlinks. Context memfs. Okay, here it is, finally. I don't know why that didn't show up for read link, but okay, so FSA, which is the file system API for the web that OPFS uses. So here for OPFS, we have to implement symlinks. This is the implementation. When we open a file, also, that's what I was trying to say a long time ago. This OPFS file system doesn't have everything that a normal file system has. It has last modified. It doesn't have created at, it doesn't have accessed. That's fine. Last modified, like we said, is pretty much the only thing that we really need. Name, that was one of the things in here. That's great. Size, we do have that. I think that's just part of the blob interface. Size. Is directory. It does have a weird file system handle has kind, which is going to be file or directory. You can see how this is weird that like normally file systems everywhere always implement the same kind of API, but this web API is like totally different in terms of how it's structured and laid out and everything.
Well, it's kind of annoying.
It is. It's weird. So a lot of what I've had to do is just like create wrappers and translate it. But the one thing it does not have is just a general. It doesn't have permissions, and permissions were part of file mode, and it doesn't have file mode. And file mode is how you store, like, is it a symlink, etc. So how do we do that? I ended up having to create a kind of my own stat, and then an in-memory map that keeps track of the metadata for any of the files that are opened. So if I change the file mode, instead of using the FSA API, it will go into this stat cache map, look up the file name, and then get the stat, and then set the mode. And then it's going to do that, and then also then go through that stat cache map, serialize it to JSON, and write it to a hidden stat file at the root of FSA.
All right.
And then when you get a reference to the OPFS file system, we will also read from that file to set up the stat cache. So now you can store file mode and all this metadata, even though OPFS doesn't support it. But it's also used as a cache so that we can quickly get that metadata, which is usually how file systems will implement it. That metadata is separate from the file so that you can access that quickly without having to open the file. Okay, so now we have file modes. We can mark things as symlinks. And we can resolve the symlinks. We can tell things not to open symlinks or not to resolve them. And we have a reference to the root or origin to be able to open absolute links. So yeah, I had to basically and in that process, I ended up just like cleaning up everything, and it's been good. So all the file system stuff is now much more consistent and cleaned up and reliable and all of that. And anyway, so that gave us symlinks, and it basically got it finally working just last night. So once symlinks worked, then we could run that init script that will install all those symlinks into bin, and then we have to see what else is going to fail. But that's where we're at with that. So we can, I guess since it's past noon, we could take a break and then come back and...
Yeah, you seemed like you're on a roll, so I didn't want to interrupt.
But that is basically where we're at. We almost have I don't know what to call it, basically a Wanix managed root. Yeah, it's not a separate file that we build. We can describe the Linux root in Wanix and then have Linux directly use that, which also means that you can do stuff like change the root for this Linux system outside of this Linux system. If we can access Wanix from outside, like over here on the console, we could like create new files and all that stuff. Anyway, I guess this is not exactly done, so. But that's, yeah, we covered everything that's done so far. We'll get this done. And again, like I said, we're almost done. I think we're just gonna, I'll leave these, I'll document these, make issues for them, and then we can focus on a release. So
All right.
5-minute break, and we'll try and get
21.
this. 21. Okay.
All right. See ya.
BRB. Where is she?
Okay, I'm back.
Yo. Okay. Let's switch this back. To where the kernel. I don't know why this is so cool, because it's like you can create a little machine that is just the Linux kernel and nothing else. And then you just point it to a server to determine what it is. There's kind of a cool demo. Steve Jobs, you know about like Next, what's it called? Next Computer?
I don't.
What? Really?
I don't
You're
know.
like
I
an
don't think
Apple
so.
person.
I mean, I like Apple computers. I don't know if I'm an Apple person. Maybe it's just because PCs are so terrible.
Maybe this is it. I mean, maybe you've heard Steve Jobs was kicked out of Apple.
And you went to Pixar, right?
He did that in parallel. He didn't go, I mean, he invested in Pixar. And so he kind of helped out. But actually, around that same time, he started a new computer company called Next Step. I think it's Next Computer. Yeah. And is basically like, oh, I'll do a better Apple. You know, he's kind of like, fine, fuck you guys. I can do this again. And so he started Next and hired Paul Rand and paid like $20,000 for this logo. Initially they were making hardware, like here's an actual computer, just like Apple. And it was like, oh, it's, you know, it was like this fancy black cube, you know, super well designed and super high end. Basically, he was like, let's go for the high end of computing and do something really fancy and premium. And it did not sell very well. However, people in the know really liked him. Tim Berners-Lee, he built the web and the web browser on a Next computer. John Carmack built Doom and a bunch of stuff around that era on a Next computer. And even though the computer didn't sell well, they also invented a whole new operating system for it called Next Step. And unlike Apple, which, you know, had a custom whatever, Next Step was like, well, let's base this operating system on Unix, because they're like, Unix actually is pretty cool. And he also really wanted to get into object-oriented stuff, because that was the other thing at Park, besides the GUI, that was really cool that he didn't even really register at the time. But then coming back around, he's like, oh, object-oriented stuff is kind of cool. And so, and he's like, it's the future. So it was, Next Step was an operating system based on Unix, but had kind of an object-oriented higher level thing going on. And so it was pretty advanced. it looked like this. But you can kind of see some similarities to Mac because basically Apple bought Next and OS 10 was just based on Next Step. So literally Next Step built OS 10. We're using this technology right now.
Yeah, I didn't know that. That's very cool.
All the APIs that you learn when you're building Mac apps are Next Step APIs. When you use class names, they're all prefixed with NS for Next Step.
Whoa, dude. That's a fun fact.
It's pretty insane. It's kind of a cool story. And, you know, obviously now, like, it runs on all these devices. And so, yeah, interesting. Why did I bring this up? Because he gave a demo. I think it's this one.
Have PostScript of any font or size. Push hide here, message. And I can put another space here if I want.
One of the features, the killer features, was it was networked. Okay, that's what I was trying to say. In this demo, he does something cool that not many people do. It's kind of like that thing where it's like, oh, if you have a GitHub repository, you can put your shell scripts in there to like customize your environment and have it consistent everywhere. They had good networking support, which at the time was pretty cool. And it was made to work in a network, you know, like you know, corporate network or whatever. Similar to Plan 9, Plan 9 was designed to work in like, you know, a distributed, like multiple computers that can be connected together. And this is actually kind of a Plan 9 thing. You know, your home directory, you create a user, you get a home directory, and in there you have all your stuff there.
Yep.
They had a system where you could boot the computer and you log in and it could pull your home directory from a file server. So maybe you have like a NAS or another computer or whatever, some kind of server that you want to store all your files in. You could keep your home directory there, and then any next computer that is on that network, if you log in, it will, your home directory will be a network mount. So it's basically like a Dropbox where you can go to any computer and you log in and you get all your files, all your applications.
Yeah, I see. I feel like I remember talking about this with you a while ago.
Yeah, I think it's a pretty cool thing that I probably would have talked about before, but and that kind of is similar to like thin clients, and there are a lot of ideas like that. But it's interesting that was like a cool advanced thing that he could do. So that, yeah, it turns all the workstations on the network into kind of like thin clients or dumb clients where your data is not on that machine, but you can still use that machine and access all your data. And then when you log out, your data is not on that machine, so someone else could use it, and you know, your data is not on the machine. So anyway, I always thought that was kind of a cool thing, and this idea of instead of Linux booting up after the kernel and then like using something on a hard drive or storage, instead it gets its root file system, which then defines everything else that happens after the kernel boots, like what is the init script, you know. All of that comes over the network, over 9p. This is something Linux can do, and it's really cool that we're doing here. So we're doing something that is, I think, a pretty cool technology that is not well known. But it's just really interesting because it makes this VM into like, as opposed to it being a machine that has like stuff on it, instead it's just like a blank machine that can boot up, and you can point it at something and it'll boot into that. You can point it at something else and it'll boot into that. We could create different root file systems that'll make it become a different machine, because everything else in Unix and Linux is defined by what's in the file system. So we are going to put it back in that mode and rebuild. And we're
It's
gonna
especially nice for like phones, like the iCloud stuff. It's just so nice you lose your phone and you don't lose everything anymore. It's like, oh, just get another phone.
Yeah.
I feel like we take that for granted.
Yeah. The cloud, Dropbox, stuff like that is very similar kind of thing. Instead of it being a remote, in a way it's simpler to implement because it's not saying, I'm going to use this file system over the network. Instead, it's just like, I'm going to synchronize. I'm going to download these files and put them locally. And then you don't have to access the network. You just use things locally. So it kind of, in a way, is a more convenient and understandable model. But,
yeah.
But yeah, effectively, it's very similar. Okay, so what's cool is we got it to boot, and we're seeing some errors here. But we still got a prompt, which is pretty crazy. Like, that was cool to see. And we can see there's that file. So it actually is our, and now we can go over here and use this to sort of access Wanix, since our Wanix is not working right now here. So we can access
Wait,
Wanix.
it's not working? You mean like the errors in the terminal?
Yeah, so it did not, so a couple of things failed in the init script, including setting up /Wanix. The reason is we're using a special device called host 9p, which lets us use the 9p protocol without having to use the network, is a common thing that virtual machines will do. And I think you can only have one thing using it at a time. So before we set up, our root file system is from the initram fs, and then we would use host 9p to set up the Wanix mount. But now this root is set up with host 9p, and so then it tries to use host 9p to do the Wanix mount, and it's like, oh, I'm busy. There's even an error here, no channels available. So apparently, maybe, I don't know, maybe you can do multiple mounts, but basically, because our init script here is assuming kind of the old thing. So we kind of just need to modify our init script, which, let's see, this is weird because we're sort of bootstrapping. If I edit init here, I think it will edit it in OPFS. Let's test that. So open it, make sure that that changes there. And then OPFS root read init. Okay, hello. So this is writing to that. So we could edit it here. That's cool. So mounting none on dev failed. None on dev. I don't know if we need to do this. Dev temp fs. Is it because it already mounting none on dev failed? Device or resource busy. That's a slightly different issue, but I'm curious what happens if we just don't do that. And then we have all of this stuff, which is mostly setting up the Wanix stuff, and we can just, I guess, not do this. We need these other things, but so we're basically just telling it not to do that mount, just to kind of clean up some of these errors. In theory, we should just be able to reload. Oh boy. Well, yeah, we broke it.
Never like to see that.
Man, was it because of dev maybe? Let's see, how would we edit that file? I guess we got to go back to this other version. And wait a minute. Oh, okay, yeah, it does have. Maybe it didn't like that we didn't do that. We'll just, so the only change here is really just not mounting Wanix. Make sure. Okay, and then I guess we gotta switch this back. Okay, well, we fucked something up.
Damn.
None of this makes sense to me, by the way. It
Really?
does. I mean, I know what a segmentation fault is. Why are there a bunch?
Yeah, I do too.
Kernel panic, not syncing. Syncing what? What does that mean here? Attempted to kill a init. So maybe a init crashed. So at least it's saying this has something to do with init, maybe. It could be that it will just do the kernel panic if your init process doesn't finish, because that basically means the computer didn't start because the init process sets everything up. So if it dies, I don't know what this stuff is. Init not tainted, and just some status stuff. But that's weird because we didn't. Okay, so I guess we'll just change it back to see. Like that. This is kind of weird. I don't think we did anything else since it last worked. Really wish we had Windows for divs.
Yeah.
I also wish that you could just like go into a mode and like drag and drop absolutely position stuff.
Yep. Well, you could make it happen.
There we go.
I mean, that sounds like a lot of work. Well, I guess not. We've done it before.
What the? I mean, we added these, so there's a last line here, but it's like hidden by this status thing, and I don't know if that's like. I guess I'm going to try and go to the end of that last line and hit return. Maybe a couple times. Okay. Maybe more so we can actually see it here. Yeah, so otherwise it looks the same as it was originally, so let's just try again and I should really add the live dir so we don't have to rebuild every time. Okay, this is stupid. Why? We didn't really do anything to it.
Yeah, it's like so down deep. I mean, you can't even add any debugging stuff, really, can you?
Kernel debug. Yeah, I mean, maybe we could like rebuild the kernel, and it's already a custom kernel, but Joel's been doing that. Yeah, I don't know. Like, in theory, if it is this script, the init script that's causing this dying, why would it be dying? Okay, I have an idea. Well, I mean, we can try a new kind of like, we'll just make a whole new simple init script and see if that works any better. I think one of the funny things is I have an implemented move. Yeah, so, but copy works. And I guess remove that and then create a new one. What does it look like? We'll do in theory we can man, this is such a crazy line. So we're basically saying, set up BusyBox, set up all the symlinks. What you have to do any of these other commands, mount, etc., because those are BusyBox commands that have symlinks. Otherwise, you'd have to say bin BusyBox and then the command. So that's why symlinks were so important. So that's set up. These, I'm pretty sure we need these, so I will leave them. And then it's just going to exec basically replaces this process with this program, basically runs this program in place. Let's try it. I think we need to, before I added stat stuff, I made it so that all the files in here have the execute bit because it needs that, so we don't need to set it. Let's try. this again. BFS root. Come on. Less segmentation faults, but oh, bin sh not found. Why is that? Shouldn't it be in there? It's called sh. I guess we could just do that instead. Oh, this is fun. We get to rebuild every time just to make an edit. Eventually, Wanix will let you, manage multiple VMs, so we could kind of do all of this without rebuilding. We just do it all from within here. So how about BusyBox SH? Since that's in theory what we're using to interpret this, so do this, forget that. I know that sometimes I think I had this before. Was I commenting this line out? Do you remember?
I don't.
Okay. I feel like I had accidentally not done that and got something similar, so could just be that. I don't remember.
Worth a try.
No. Okay. What? Okay. Well, I know what's going on. The whole that crazy man. What is going on? This last line is crazy in part because we're telling it to run this shell with its input and output being sent to TTY S0, which we have wired up to the terminal. So by not doing this, it's not sending the shell to the terminal. We just have to use it here in this, in which we can't copy and paste or anything. But weird though that it worked, sort of. Can we even do anything? Okay, but we can't. Is there maybe something wrong with BusyBox? I guess we could turn on 9p. Debugging to see if there's anything interesting there. And I don't know, are we doing... Oops. Get adder for what? file, doesn't it? I thought it includes. Weird. Oh, it's using a FID, so we don't know which file it is. Trying to look in etcd for password. I don't know why it would do that. I mean, I can imagine it's like, oh, I'm gonna do a login user thing. That's this file has, you know, user accounts, passwords, and stuff. The shell here is called Ash. By the way, it's kind of like Bash.
The browser.
The
console.
The shell that we run, that BusyBox comes with. BusyBox has like a bunch of stuff that you need for a Linux system, including a shell built in, but its shell is not like Bash. It works a lot like Bash or whatever, but it's actually something called Ash. Okay. So it's accessing a lot of files. I don't know if it was accessing before. But it's weird that it worked before. Like, what exactly? Yeah. We basically... I mean, I guess it's possible that it could have written files to our root that somehow changed its behavior. I guess we could see if there's any unexpected files in here. Like Ash history, that is our you know, as you use a shell, it will keep a history, and so it wrote that file. I wonder if it has to do with the symlinks. Because before, we sort of assume we don't have the symlinks, so it's creating the symlinks every time. Now it's created those symlinks, but it did it on this persistent thing. And so now are these, you know, maybe something about my symlink implementation is causing these to not work? Like, that kind of makes sense. We're trying to run certain things and it just doesn't work.
Well, that sucks if so.
Let's try. Yeah, let's try ls. We'll do a stat. I have no idea what file mode that means. Presumably that means it would be a symlink. I guess we could read it. So yeah, a symlink would point to /bin busybox. Huh. That's interesting.
What's interesting about it?
Well, I'm just wondering if it has to do with my Symlink resolution. And interacting weird with Linux's expectations. What? I feel like that could be it. But I'm trying to think, was there a time when we used OPFS root and the symlinks were working? Because originally it put us in a shell, but I don't remember how much I used it, so I don't remember if it worked, if things were broken. It definitely didn't complain.
Do you do you have the version in GitHub that you could revert it?
No. Well, here's the thing: is this OPFS stuff is very it really just lives in the browser. Oh, that's what I did. I think I mounted a directory in and I copied it to OPFS to persist it, so I could kind of do a fresh root if I could remember what maybe it was this LinuxFS. There's one symlink. That's weird. And then
It is just about one. I don't know what you want to do. Hate to end on a bummer note, but
yeah.
although maybe some of this debugging would be better off stream.
Yeah, when it goes slow, it's not as good. But yeah, I was hoping we could get it done. But I guess it'll probably be done by Wednesday. So I guess we could just wrap up, stream.
Womp womp. So what are your next troubleshooting steps?
Well, I'm gonna copy in a new root file system for Linux based on what I think I used to make that one. And that'll just kind of reset the root to what it was back when it worked, I think, and just see if that works. I have a feeling it could be related to Symlinks. Because that's, code that I wrote, so that's probably broken. Since everything else seems fine.
Well, I hope you find it fast. I hope it's not like some big issue with your Symlink stuff.
It should be quicker than actually implementing Symlinks.
Oh, that's good.
Yeah. Okay, well, so I guess that's it for today. We'll be back Wednesday.
Alrighty. Bye, people.
Bye, everybody.